example 4, the shadow problem. Ethan, who's 6 feet tall, walks away from a street light at a rate of 5 feet per second. If the light is 18 feet above ground level, answer the following question. Now, I can tell you this. I see this quite often, especially in the multiple choice on the AP exam. So it's definitely worthwhile doing. The key is that we need to look at what's happening. So I'm going to draw a picture first. Here's the light. And what's Ethan doing? He is walking away. So we essentially have sort of two right triangles, or two right similar triangles. So here's Ethan, he's right here, and this is the lamppost up here, LP, right? Just like in the picture there. This piece here that doesn't change is 6 feet. And, oh, that's inches. No, Ethan just got real short here. Is 6 feet, and the lamppost is 18 feet. Those are unchanging. Those pieces of the picture is not going to change. Ethan is not going to change his height unless he walks like a lot and gets shorter and shorter, shaves off a piece of himself each time, which sounds silly. The lamppost is not going to change, right? But this distance here between the lamppost and Ethan will change, and the distance of, or the length of his shadow will also change. So those are both changeable. So I could assign variables to those pieces, like, for example, X and Y. So those things change. So then it says, how fast is Ethan's shadow lengthening? So according to this, what I've defined here, I want to know what dy dx, or dy dt is equal to. That's the question, right? So for us, we need to find an equation that we can base this on. So what we're going to use is similar triangles. So I'm going to draw, sometimes it helps drawing the two triangles separately. So we have this big triangle and the small triangle. The small triangle, this is from geometry. By angle similarity, these two are similar. So this is 18 and that's 6. The whole length here is x plus y on the big triangle, and the corresponding length in the small triangle is y. So then I can set up a proportion that says that 18 over 6 is equal to x plus y over y. Or you could do 18 over x plus y is equal to 6 over y, whichever you like. The key is we're going to cross multiply here and just simplify a little bit. So I haven't taken the derivative with respect to time at all yet. I'm just developing the formula. So I have 18y is equal to 6x plus 6y. And I'm going to, again, ensure that I just have a single term for y. It's easy enough to simplify this. So this is going to be 12y is equal to 6x. You could move everything to one side, but it's also fine just to leave it. Now I'm ready to take the derivative with respect to time. We have here d dt of both sides. So that's going to give me 12 dy dt is equal to 6 dx dt. And let's see what's missing. It's saying here, Ethan, who is 6 feet tall, walks away from the street lamp at a rate of 5 feet. So I know that his rate, that's this in red that I'm highlighting here. Let me highlight it. That distance right there is changing at a rate of 5 feet per second. So that is going to be dx dt is going to be 5 feet per second. Okay, so then it says, if the light is 18 feet above the ground level, answer the following question. How fast is Ethan's shadow lengthening? Well, all I have to do then is substitute in for dx dt, which I know is 5 feet. per second. So that's going to give me 12 times dy dt is equal to 6 times 5. And then dy dt would then equal 30 over 12. Oops, 30 over 12. And it should be positive because his shadow is lengthening. I'm taking up too much room here. 30 over 12, like so. And 6 goes into both of them, so I guess it would be 5 over 2. So 2.5 feet per second. Ethan's shadow is lengthening. Oh, that's terrible. At a rate of 2.5 feet per second. Like that. So similar triangles. Now it would be different. So if I was just asking how fast the tip of the shadow is moving. Now that's a completely different question, because that's, if you can imagine putting a remote control car at the tip of his shadow, he's moving away from the light. Both the length of his shadow and him are both moving. So the point out here that I'm highlighting right there, that's the tip of his shadow as he's moving, right? You need to anchor that to something that is stationary. Now, Ethan is not stationary. He keeps moving. So I need to relate that back to the lamppost. If it was asking for how fast is the tip of the shadow moving, I need to compare that against something that is not moving. So I would then instead, if that was the problem instead, sort of very similar, except I would then define this as y instead. This would still be x, but the whole distance would be y, because then I would be looking for dy dt again, like that, for the whole thing, like that. So then in this case, or you could pick a different variable, it doesn't really matter. So in our case here, we would then, by similar triangles, Ethan is still 6, the lamppost is still 18, and when I know this little piece would be y minus x then. So the setup for the equation that I would use in this case instead, if I drew the two triangles, would be 6, this would be 18, this whole length is y, which is what I'm looking for, dy dt, but this now is going to be y minus x. And the reason why I need to do that is that dx dt is still the speed at which Ethan is moving. He's moving at 5 feet per second, right? Feet per second. So that needs to still be there. So then we're going to set up the ratio again. We could do 18 over 6 is equal to y over y minus x. Cross multiply, we get 18y minus 18x is equal to 6y. And then we end up with 12y is equal to 18x. Take the derivative with respect to time on both sides. 12y is equal to d dt of 18x. So that's going to give me, I didn't leave much room for these. 12 dy dt is equal to 18 dx dt. And then I'm going to, I know what dx dt is, and I have to solve for dy dt. So substitute in, you get 12. So it looks very similar. The answers are not the same because it's going to be 18 times 5 here and then divide by 12. So dy dt is equal to, but I can't reiterate that enough that it's going to be the tip of the shadow is changing. So it's going to be 15 over 2, which is equal to 7.5 feet. Is it feet per second? So then the tip of Ethan's shadow is moving at a rate of 7.5 feet per second. Now, an interesting observation, by the way, is that the length, I'm going to draw up here in the original picture, this in green, we're concerned with how much this length is changing. Well, if I had already done part A and they weren't two completely separate problems, right? If on a test, if it's a free response, I know that I want to see how much that green changes, that green segment changes. Then I can just take it's x plus y, so for that entire length. So the rate of change would also just be dx dt plus dy dt. So I found out that Ethan's length shadow is changing at 2.5 feet per second, and he's moving at 5 feet per second. So essentially those two rates get added together to give me how fast the tip of the shadow, which is 7.5. So you get the same value. I'm just trying to show you two different ways you can find it.